today we'll be looking at one of the principles that governs equilibrium, and that principle is known as the Chatelier'S principle. Okay, so the Chatelier'S principle states that if a system is under equilibrium, a system under equilibrium is affected. I repeat myself again. The Chatelier'S principle states that if a system is under equilibrium or is undergoing equilibrium, okay, and that system is affected by some constraint, okay, or factors such as temperature, pressure, and concentration, the system will adjust or try to neutralize the effect of those concentrations by shifting from one point to another in order to neutralize the effect. So this principle is an important principle that governs or that helps us to know, calculate, or predict or be able to ascertain the equilibrium constant of every reaction, and also to be able to know the yield of that reaction. Okay, so now those three factors that can affect a system in equilibrium include temperature, pressure, and what? Concentration. Okay, so now how does temperature affect a system in equilibrium? Okay, how does temperature affect a system in equilibrium? Now remember that in a system, heat can either be absorbed or released. Okay, so if heat is absorbed by a system, that reaction is said to be an endothermic reaction. Okay, but if heat is released by that system, then that reaction is said to be an exothermic reaction. Okay, so let's start with temperature. We already talked about temperature. Okay, we said that for a system, if a system absorbs heat, the system is said to be an endothermic process. Okay, if the system releases heat to the environment, it's an exothermic process. But how do we recognize an endothermic and exothermic reaction from a chemical equation? Okay, we can get that by looking at the enthalpy or the heat of reaction. If the heat of reaction is positive, if the heat of reaction or the enthalpy change is positive, what it means is that the heat of the product is less than the heat of the reactant. Okay, well, that's what it means. If the heat of product is less than the heat of the reactant, then the enthalpy change is going to be a positive value. Okay, and if it's a positive value, it means the reaction will be an endothermic reaction. That is, heat will be what? Absorbed. That will be heat will be absorbed. Heat will be absorbed. So if heat is absorbed in an endothermic process and you are increasing the temperature of that system, let's say you are increasing the temperature when heat is absorbed, or and the process endothermic, the equilibrium constant will shift to the right. And shifting to the right means that it is going to favor the forward reaction and also going to favor the what? The product formation. But if the reaction is negative or exothermic, that is, heat is released. For this case, if the reaction is exothermic, okay, it means that delta H is negative, right? If heat is released, that is, everywhere is hot, heat is released, and you are increasing the temperature, the equilibrium will shift towards the what? The left. To shift towards the left, and it will shift to the left, favoring the backward reaction and also favoring the reactant formation instead of the product what? Formation. So in the industry, these things are being monitored so in order to get a maximum yield of product. Okay, you have to know the right condition that can proceed a reaction to go towards the product side, and rather than coming back to you to the reactant side. So this is how temperature can affect a system in equilibrium. Okay, so the second effect of the effects that can affect a system in equilibrium is concentration. Okay, concentration, effect of concentration, right? We have talked about this. Okay, you know how temperature can affect the system in equilibrium. Now, how can concentration affect a system in equilibrium? Now let's look at this reaction. Let's say we have a reaction A plus B reacting to give us C plus D. Now, how can these concentrations of each of these things affect the reaction? How can it affect the reaction in equilibrium? Now, let's assume that we are adding A or B. We are adding more A or B to this reaction. If you add more A or B to this reaction, remember the reaction is already going on. If you keep adding more A or B to this reaction, you are going to favor the formation of this C and D. That is, the equilibrium constant will shift, will be going forward to to the product side. So you are favoring the forward reaction, okay? But if you are removing this A, as you are reacting, you are removing this A, the equilibrium constant will be coming backward towards this A. So addition of the reactant favors the opposite side. Addition of this reactant will favor the opposite side, that is favoring the forward reaction. But removal of the reactant will favor the reactant, the formation of the reactant. So the reaction, so look at this table here. Addition of A or B favors the opposite side, which is C or D. Removal of A or B, which is the reactant, will also favor the A or B, that is formation of what? The A or B, that is the backward reaction. Okay? Now addition of C and D favors A and B, the opposite, right? If you keep adding more of this guy, you are going to be favoring the formation of what? The reactant. Okay? While removal of C or D, this or this, will favor the product side. So understand the concept behind this effect. Okay? So the more you add the reactant, the more you form the opposite side. The more you remove the reactant, the more you form the reactant. Okay? So this is the effect of concentration towards equilibrium constant. So with this, you can be able to now know how to monitor or how to predict your reaction, or how to alter it to suit what you want or what you want to produce. Okay? Alright. So for pressure to affect a system in equilibrium, these two conditions must be met. Okay? There must be a gaseous component in that equation, or in that expression. Okay? For example, if I have something like this, let's say I have hydrogen combining with iodine, sorry, to give us hydrogen iodide. Okay, this is gaseous, this is gaseous, this is gaseous. Okay, so this equation satisfies the number one condition. Okay, there must be a gaseous component. Once you have seen one gaseous component in the equation, then pressure can have an effect on the system. Okay, then number two is that the delta N, remember I told you that change in N simply means change in number of moles. Change in number of moles. Okay, change in number of moles. So this change in N in number of moles can be calculated by number of moles of the product minus the number of moles of the reactant. Okay, so how do you get this number of moles? This number of moles is gotten from a balanced equation. This equation, is it balanced? No. I have two hydrogen atoms here, I have two iodine here. To balance these two, I'll have to put 2 here. Okay, so that change in N will be equal to 2 minus 1 mole is here, 1 mole is here. 2 minus 2 is equal to 0. Now anytime you calculate this thing I've just done here, and this change in N gives you 0, then it means that pressure can never have an effect. Okay, it means that pressure can't affect the system. Okay, it means that pressure can affect the system in equilibrium. Okay, so now once these two conditions are met, then pressure can have an effect on the system. For example, let's say we have something like this: nitrogen combining with hydrogen to give us ammonia. Look at this equation. Okay, look at this equation. This is gas, and this is gas. Okay, now look at this equation. Is it balanced? No. To balance it, I have 2 nitrogens here, I have 1 nitrogen here, I'll have to put 2 here. So 2 nitrogen means 2 nitrogen. Okay, balanced. Hydrogen is 2, 2 times 3 is 6. I'll put 3 here. So I have 6 hydrogen. Okay, now look at this equation. Let's check if it obeys the first rule. Yes, there is a gaseous component, and yes, change in N is not 0. Why is it not 0? Because from here, look at this expression, from here, the change in N is, here I have 2, I have 3 plus 1, which is 4. So change in N for this is 2 minus 4, which is equal to minus 2. So looking at this equation, you will see that the change in N is minus 2 and not 0. Now, if the change in N is not 0 and there is a gaseous component, what it means is that if you increase the pressure of this system or decrease the pressure of this system, there will be an effect. Now, according to the Chatelier'S principle, if you increase the pressure, look at this statement now. If you increase the pressure of this system, the equilibrium constant will shift to the side that has a reduction in mole or reduction in volume. Look at here. I have 1 mole here. I have 3 moles here. Okay? 1 plus 3 is 4, and I have 2 moles here. If I increase the pressure of this system, the equilibrium constant will shift towards the side that has a lesser mole. From 4 to 2, it will be what? Shifting towards the product side. So if there is a reduction, in mole, just like from 4 to 2, the equilibrium constant will shift to the what? To the product side, thereby shifting to the right. Okay? So it will shift from what? From the left to the right. And if it shifts from the left to the right, it favors the forward reaction. So the other, it goes vice versa, okay? So equilibrium constant for pressure shifts to the side that has a lesser or smaller moles. For this condition, it's going to shift to the product side because here has 2, here has 4. So if you reverse this reaction, and you still increase the pressure, the equilibrium constant will shift now to the what? To the left, because of the fact that these 2 moles will be to the left. So pressure has an effect depending on the what? On the mole reduction or mole increase. So these are some of the applications of this Chatelier'S principle. You can actually use this to, in fact, in the industry, this concept we have learned here will help you to understand the contact and the Haber process, how it works, okay? It will help you understand. So we are quickly going to look at 1 or 2 applications of these principles to understand fully how the Chatelier'S principle works.